Welcome back my YouTube family. I'm your instructor. My name is Rashid and today's video we are diving into the fascinating world of data analysis using Python. We will be working with a real data set, heart disease. So before starting this, you must visit this playlist. In the previous episodes, we have completed the data analysis with Python on FMCG sales dataset and we did sales prediction by using this data as well. So I will recommend you to watch these episodes as well. So this is our dataset. Before starting the analysis, we must understand the dataset. So in our dataset, the first column is for age. There is not a specific normal or dangerous range of age concerning heart disease. However, as people age keep increasing, the risk of heart disease generally increases. Lifestyle factors and overall health become crucial. So in our dataset, we simply having the ages of the respondents. In the second column, we are having the gender. 0 represents the female and 1 represent the male. Both genders can be affected by heart disease, but the risk factors and symptoms may vary. The third column of that dataset is CP, chest pain. Basically, we are having the 4 chest pain types. The first one is the typical angina. Typical means simple, common. So this is a common chest pain heart. Chest pain related to decreased blood supply to the heart. A typical angina. Chest pain that is not typical but could still be related to the heart. This is not a common one, but this is related to the heart. Non-anginal pain, chest pain not related to the heart. Asymptomatic means a person doesn't feel any chest pain, but it doesn't guarantee there's no heart disease. Sometimes heart issues can be there even if you don't notice any symptoms. So in my column, if I'm having 0 means typical angina, 1 mean atypical angina, 2 mean non-anginal pain, and 3 mean asymptomatic. So here you can see 0, 1, 2 and 3. So the next one is resting blood pressure. Normal resting blood pressure is typically below 120 by 80 mmHg. High values may indicate hypertension, a risk factor for heart disease. So if the values of this resting blood pressure is more than 120, so that means there can be issue. Next one is CHOL, serum cholesterol. So desirable total cholesterol is generally below 200 mg/dl. So the value of this CHOL must be less than 200. If the values are more than 200, there are more chances of heart disease. So the next one is fasting blood sugar. Level above 120 mg may indicate diabetes or pre-diabetes, which are risk factors for the heart disease. So if the values of this fasting blood sugar is more than 120, then it is showing 1, and if the value of the fasting blood sugar is lower than 120, then it will be 0. More, I have added this text here. If the values of fasting blood sugar is more than 120, then it is represented by 1, otherwise 0. So next one is the resting cardiographic results. So there are 3 types of this one. 0 is for ideal, 1 is for abnormal. STT waves on a heart test could mean there are problems with the heart, and the second, left ventricular hypertrophy, means the heart left pumping chamber has gotten bigger. It could suggest that the heart has enlarged. So now if I'm having my value 0 means normal, if I'm having 1 means abnormal ST, and if I'm having 2 means left ventricular hypertrophy. So the next one is THALACH, maximum heart rate achieved. The usual top heart rate during exercise is around 220 minus your age. If your heart beat much faster or slower during exercise, it's something to pay attention to, as it could indication to concern. So the maximum heart rate achieved must be around 220. So if the value is less than 220 or more than 220, that means there can be a problem. So the next one is EXANG, exercise induced angina. When it's 1 for exercise induced angina, it means chest pain happens during physical activity. So here, if the value is 1, that means there is a pain during the physical activity, and if here is 0, that means there is no pain during exercise. Next one is OLD-PEAK. Old peak means ST depression. If the value of ST depression is higher, that means there are high chances for heart disease. So as the number of this column will be higher, the more chances to heart disease. So the next column of our data is slope. When doctors look at your heart activity during exercise, they pay attention to how a specific line on chart behaves. So there are three types of behavior. Upsloping, a gentle incline, is generally okay. Incline means moving upward. Flat, staying horizontal, might raise some concerns. Downsloping means moving downward. A downward trend could signal potential issues needing more investigation. So here 0 means upsloping, 1 means flat, and 2 means downsloping. So the next thing is CA. Doctors use a special camera test called fluoroscopy to check your heart's blood vessels. If they notice more colored area during this test, it could suggest a greater chance of having heart disease. It's like a sign that the blood vessels in your heart may not be as healthy as they need to be. As the number of this CA increases, that means there are more chances of having heart disease. So the next one is THAL, thallium stress. So if the value of this column is 1, means normal, 2 means fixed defect, no blood flow in some part of the heart, and if the value of this column is 3, means reversible defect, blood flow is observed but it is not normal. And the last thing is the target, means if the value of this column is 1, that means the heart disease is there. If the value of this column is 0, that means there is no heart disease. As you can see here, 1 indicates the presence of heart disease, 0 indicates the absence of disease. So basically this is the introduction of the data. Now we will be moving toward the analysis part. We began by importing the essential libraries for data analysis. From here I will be selecting this heading. Okay, shift enter from my keyboard, so it will convert this into heading. So my first library is for pandas. Import pandas as PD to handle data. Matplotlib for plotting, and Seaborn for enhancing visualizations. As you will press shift enter from your keyboard, the static is converted into 2. That means this code is executed correctly. Now we load our dataset, which is a table of information using pandas. My data is stored in this folder, and from here I will be copying this link from here, returning back to my notepad, and here I will be typing df for data frame is equal to pd dot read underscore excel, and in inverted commas I will be pasting that link, and here I will be typing the name of the excel sheet .csv. So here I will convert this Excel to CSV because my data is stored in CSV file, and I will press shift enter from my keyboard. So I will be typing df.head and I will press shift enter. So basically this is my data that I already explained each column of that data set. Similarly, we check the last few rows of our data set. So I will be typing df.tail. So this is giving me the last 5 rows from the dataset. As you can see from this serial number, we find out how many rows and columns our dataset has. So for this I will be typing df.shape, and if I will press shift enter from my keyboard, it is showing we have 1025 rows and 14 columns. If you will count from 0 to 1, 0 to 4 will be 1025, and we have 14 columns. So by this we can check out the columns and the rows of our dataset. We get information about our dataset such as data types and the presence of the missing values. So for this I will be typing df.info, and if I will press shift enter from my keyboard, it is giving me the data types int. This is my float, and it is also showing I don't have any null values in my this dataset. Now we check for any missing values in our dataset and count them. I will be typing df.isNull.sum, and if I will press shift enter, it is showing I don't have any null values in my this dataset. Okay, fine. We check if there are any duplicate rows in our dataset. For this I will be typing df.duplicated.any, and I will store these duplicate values in duplicate values and print these values. Press shift enter from my keyboard, it is saying true. True means I have duplicate values in my dataset. So now I have to remove all the duplicate values from my dataset. So for dropping the duplicate values, I will be typing df is equal to df.drop duplicates. Now if I will typing df.head, this is showing my dataset, and if I will be checking df.shape, Now this is showing I'm having only 302 rows and 14 columns. Before I'm having this 1025 rows. Now all duplicate values are removed from the dataset and I'm having 302 rows. Think of duplicate like having the same song in your playlist. If you are having one song for 2 times in your playlist, obviously you will delete one and unique song will be there in your playlist. This code checks and remove same rows in our data, making sure each information appears only once. This is like avoiding hearing the same song for 2 times. So now we are going to explore the relationships between the variables. So here I'm going to heading and I will press OK. So now I'm going to type df.correlate. df.correlate calculates the correlation between different columns in our dataset. Correlations measures how strongly two variables are connected or related. If I will press Shift Enter from my keyboard, now you can see this table. Here I'm having my variables and here I'm having their correlations with the target. So all the values having negative values means having very less correlation. CP chest pain, this is having the value of 0.43. This is a positive value, means there is a positive correlation between CP and target. Means if the value of the CP is in dangerous position, that's mean there are more chances of having heart disease. Resting cardiographic, this one and this slope. So these variables having big impact on having disease or not having disease. There is a positive relationship between these variables having the value in positive. Now here I'm going to write sns.heat-map. I will press Shift Enter from my keyboard and here I will be typing a naught is equal to 2. Shift Enter, so it will show the values on my graph, and now I will be typing plt.figure into fixed size parenthesis open. Now if I will press Shift Enter, now you can see this heat map. So if the values having 0 or negative values will be in this dark color, and as the values will becoming positive and going toward 1, the color will be changing. For example, this is 0.43 correlation of CP with my target. This is lies like here. Similarly, this resting cardiographic, this one and this one. These values having positive correlation. So now we are going to calculate the persons who are affected or unaffected by heart problem. So I'm going to select this heading, OK, and Shift Enter. So here first of all I will be showing my columns, df.columns. So these are my columns and my answer is in target. So here I will be typing sns.countplot and I want to count plot this target because my answer is in this column. So here I will be typing my data frame is df and in df I want to calculate or count plot this target. So I will press Shift Enter. 0 means the persons not affected by disease and 1 these persons affected by disease. So the height of this plot showing the number of persons. If I want to remove this text, then I will be typing plt dot. So this text is removed. Now we will be checking the gender distribution within the data. So here I will be selecting this heading, OK, Shift Enter. So first of all I will be checking my columns, df.columns. So these are my columns and my answer is in this sex column. So here I will be typing sns.countplot and I will be counting df in df. Now I will press Shift Enter from my keyboard. If I want to remove this one, then I will be typing plt.show, Shift Enter. Now this x-axis having 2 bars, one for each gender, 0 represent female, 1 represent male, and the height of each bar represents the count of individuals belonging to that gender. This graph helps you quickly understand the gender distribution within your data. So now we are going to check the distribution of heart disease among males and female. Heading, OK, Shift Enter. So first of all going to write df.columns. So these are my columns. Now I'm going to type sns.countplot. In countplot my data is data frame and on x-axis I want my gender and I want to distribute my gender on the basis of target, on the basis of disease or not disease. So if I will press Shift Enter, this is showing me 0 for female and 1 for male. So now here I'm going to write plt.xx. So if I will press Shift Enter, again I am typing plt.legend labels is equal to no disease and here disease. plt.show Now if I will press shift enter, now this is showing me in simple terms. This graph helps us see the distribution of heart disease among males and female. Basically this is female and this is the segregation of no disease and disease. This is male, no disease and disease. Now we are going to check the age distribution in our data set. From here I will be selecting this heading. Okay, when I will press shift enter, it will convert it into heading and send me in the next row. So here first of all I will be checking my columns. So now here I will be typing SNS dot distribution plot and I need df square brackets age. Here I will press shift enter. So this is my plot and here I will be setting the bins is equal to 20. Shift enter and plt dot show. So basically this is my histogram. In simple terms, this chart gives us a visual sense of the age distribution in the dataset. This P curve shows the major respondent of this study lies from 50 to 60 age, means below 40 I have less respondents. So major respondents lies from 50 to 60 age. So now we are going to identify what kind of chest pains are there in this dataset. I'm selecting this heading. Okay, shift enter from keyboard. So I'm going to this code, I'm copying this and pasting it here and I will replace this with CP. Shift enter. So these are my 4 chest pain types. As you can see, on 0 this one, on 1 this one, on 2 this one, and on 3 this one. So similarly this is showing 0 1 2 3. Now I'm going to replace these indexes with the names. So I'm typing plt dot x ticks in square brackets. I'm having 0 1 2 3 and here I will replace the names. So these are my names. Now if I will press shift enter again, so now you can see the typical angina is the most common chest pain as per this data set. Now we are going to explain the distribution of chest pain on the basis of heart disease. So now I'm making this heading. Okay, shift enter SNS dot count plot and in count plot my data is equal to df and in x I need cp, means on x-axis I want to paste this cp. So I have 4 types of cp in this data and u should be this target and I will wrap this cp in comma as well. And if I will press shift enter from my keyboard, now I will be typing plt dot legend into labels. So 0 mean not and 1 mean disease. And here I want to shift enter. So this is my count plot that is showing me the distribution of chest pain. So here you can see 0 means typical angina having this portion of persons with no disease and this portion disease. If you can see this section, this non-anginal pain cause more persons with heart disease, even in atypical angina. So atypical angina and non-anginal pain are the major causes for the heart disease as per this data is showing. So now we are going to checking the data distribution with reference to the resting blood pressure. So I'm writing resting blood pressure distribution overview and from here I will be selecting this heading. Okay, and shift enter from my keyboard. So first of all I'm going to type df dot columns and I want to use this one resting blood pressure and I will be typing df. In df I want to assess this column dot hist and shift enter from my keyboard. So basically this is showing the data distribution, the distribution of resting blood pressure values. So the major values are between 120 to 140. So as per the discussion, if the values of the resting blood pressure is more than 120, if these values are higher than this, indicate hypertension. So how I have to read this histogram? You can say there are 10 respondents whose resting blood pressure falls under 100 and almost 20 or around 1 or 5 or 6, around 70 having more than 120 and around 15 respondents having resting blood pressure till 160. So that's mean if the values of resting blood pressure is high, there are more chances for heart disease. Interpret this data like this. Now we are going to check the data distribution on the basis of serum cholesterol. From here I will be selecting this heading. Okay, shift enter from my keyboard and I'm going to copy this data The serum cholesterol column is this one, CHOL. I'm copying this here and again I will be pressing shift enter. So this is my data distribution for serum cholesterol. So as per the presentation, the value of the serum cholesterol must be below 200, and if the values are higher than 200, that means there are more chances for heart disease. So as per this data, I'm having almost 100 respondents having serum cholesterol more than 200. So I'm having only like around 70% having the values of serum cholesterol within normal range, and major are having more values for serum cholesterol as per this diagram.